Introduction to Masonry. In this presentation, we will be looking at introduction to any historical development that is important for Masonry, the type of Masonry uses and uniqueness, Masonry wall requirements, and the use of types of Masonry mortar. Introduction to historical developments in Masonry. Masonry is a wonderful construction system. It is the simplest of all building techniques. The idea with Masonry is just stack together different elements, normally are bricks, stones, blocks, and we put them one in the top of the other, using a binding material that can be mud, mortar, and others. The medieval and Islamic civilization perfected Masonry and did wonderful buildings and palaces. Some of them still in use in many countries, especially in the Middle East. They also use some very beautiful bright glazed styles. The Europeans, they also built fortress, cathedral, and they discovered the arch and were able to use vaults and beautiful elements like flying buttress that structurally help to allow Masonry to reach a very high level of structural perfection. In America, in Asia, other cultures also built with stones. During the Industrial Revolution, machines were developed, and it was possible to cut the stones and mold the bricks in an easier way to speed the transportation of these materials, and it became quite popular. Portland cement also became popular in that moment, and it was possible to build walls with a strong strength and durability than in the past. In few words, Masonry have a rich history. Through the 1800 was the primary building material, and in the late 1800s, new products were developed, and in some places, the Masonry dominance finished. However, in many countries around the world, Masonry is the most important building system. It is believed that more than half of the world population live in buildings made out of earth. I mean, materials using dirt, like bricks. And the proportion of people living in Masonry buildings is even bigger. In the 20th century, we have new developments in structures, like the appearance of the steel reinforced masonry, where we have steel inside of the masonry, mortars that were much stronger, masonry units also that have a high strength, and start to appear a variety of size, colors, textures, and coatings in the materials. Today, Masonry is used especially in the United States and in the south of the states as a concrete masonry units. And that is for foundation walls, for structural support walls, for backup walls, for exterior facing. Also is typical the use of brick and stone, mostly as a facing material, like a veneer, or in decorative walls. Something very good of masonry is that it's unique among other construction materials. Masonry have a very strong fire resistance. In fact, most of the masonry products, like bricks, have been cooked with fire to make them stronger. Also, masonry have small sizes in comparison with other material. The material is small, and one person can build a building out of masonry because it doesn't need to carry big loads. The durability of the masonry is very strong. we can see many buildings made out of bricks that are thousands of years old. It would be very difficult to find buildings that are that old when they are made out of other materials like wood, and even the concrete do not have the same duration of masonry. In some countries, masonry is used as a material that is not cooked, but the bricks are dry in the sun. It's a kind of traditional construction that is typical in many developing countries. And even in the United States, in the area of New Mexico, these adobe techniques are very common. In Iran, they even build houses, and after they make a fire inside of the house, and this fire will cook the material and obviously the mortar between the pieces, and the house will become much more strong. In the States, for the contrary, CMU are more common, especially in new constructions. You will be able to see many buildings out of bricks in the north of the United States. In the south, it's less common, and CMU are the most popular. They are usually used in the United States in basements. We don't have so many basements in Florida because our phreatic level of the water, but you will find them in many other places. Also in the States, CMU is used as a structural wall for low-rise buildings. Sometimes the CMU is not even reinforced. In this picture, we have a reinforcement in a part of the building because the span is much bigger. In some countries, for the contrary, it's forbidden to build buildings of more than 1 or 2 floors if there is no reinforced still inside. Reinforcing structural CMU is made with concrete, and usually in the superior part of the building and in the base of the building, you will have an area where you will have concrete and steel also as a columns to make it stronger. The CMU, concrete masonry units walls, also are used as a structural walls that serve as a backup for a brick facing. This kind of brick facing most times do not have any structural value, it's just for decoration, and it can be made in good ways or in a very bad ways, like in this home that have an excessive types and colors of masonry units that are not structural. When we have masonry walls, we need to understand that one of the challenges is to make openings in the walls, because masonry walls usually are walls that are supporting its own weight and the weight of the roof system or other floors that are in the top, and making openings make the wall not as strong. Therefore, we need to look ways to do those openings. We can have lintels, we can have corbels, we can have arch that are used to support the openings in masonry walls. Our construction and bolts is something that date from thousands of years ago, and the idea is to make a span and divert the weight of the openings to either side of the opening. Arch usually are curved, and obviously the blocks need to be ground down and wedge shape, or the mortar joints will be tapered. Also, we have lintels. Lintels are like beams that are made of reinforced concrete, blocks of steel or any other material, and that will span one side to the other of the opening. Well, we can look here a lintel, and we can look some examples of arch. Mortar functions. Between the bricks, we have a mortar. And the mortar is a very important material. It will provide for full bearing. I mean, we will not have space between the different pieces that do not have material, and it will have a better bearing. It will seal the different masonry units between them and will adhere or bond the masonry units. And it's also surface enhancer. From the aesthetic point of view, can be something good. Well, we have here a little bit longer explanation of the use and types of mortars. And most mortars are made out of Portland cement, hydrate limes and aggregate like sand, and obviously water. Well, the Portland cement is the bonding agent. The lime will make this material more smooth and easy to work. And the sand will be the cheap material that will produce the bulk around the lime. And the water will help to the workability and obviously to chemically allow these materials to be together. When we have hydrated lime, that will also allow an absorption of CO2 from the air, and the mortar will become stronger. The masonry mortar have several names and will have the materials that we spoke before: Portland cement, Portland pozzolan cement, or natural cement, or slag cement. Some types of cement, sometimes hydraulic limes, or hydrated limes, limestone, chalk, shells, talc, slag, clay, and other type of sand materials will be used to produce it. Sometimes we can have a contrast between a brick and the mortar, and sometimes we have a color blend, like we can look in this photo. The mortar can be prepackaged. Usually in the States it's prepackaged. In other countries it's made with the different materials on site. The color range is huge and obviously depends of the composition of the earth, and it needs to be tested, and there are specifications that are strict about the different types of mortars that we can have. The mortar needs sometimes to cure, to dry properly in order to become stronger, and also have a shelf life when it's prepackaged. There are many types of mortars, and it depends of the materials and the proportion of the materials between them. Usually in order to have some workability, we will have some mixtures that will allow a higher content of air in the mortar, but it's not so good for the strength of this material, but will allow us to work with it better. Most times, these kind of materials are related with lime mortars that will be drying, and the absorption of CO2 from the air will allow to form a better mortar. Mortars have several types. It can be M mortar or M type, that is the one with high strength. It's about 2,500 psi, pounds per square inch. It is used for buildings that have a lot of lateral loads and in areas that were building below the grade, below the earth level, because the pressure of the surrounding dirt walls around the building will be strong, and the mortar need to be special. There is also an S-type mortar that is medium high strength mortars that have about 1,600 psi, and is used for masonry structures when you need like a strong bond between them. The medium mortar, strength mortar, is about 750 psi and is for general use of any construction above the ground. And the odd type mortar is used for no load bearing walls and partitions in the buildings. You need to memorize the PSI values of each type of mortars. The use and type of mortars depends of the proportion of the materials. And here we can look at the proportions that an M mortar, S mortar, N and O type mortars will have. For example, the materials will be Portland cement, hydrate, lime, and sand. An M-type mortar may have 1 part of Portland cement, for example, 1 part of hydrate lime, and 0.2 parts of 3 parts of sand. And those proportions will change. You don't need to memorize the proportions because you can find them easily on the internet. This concludes the presentation.